Okay, we're going to go through a little bit more around reactions now, and this time we're introducing the concept of inclined forces and horizontal reactions. They work pretty much exactly the same way as the vertical reactions, just in a different direction. So, our prior knowledge all centered around vertical forces, and we use free body diagrams like this. Now, what if the force was actually pushing or pulling at a different angle? The notion of an inclined force was explored in Unit 1, and we learned how to solve those inclined forces, but they were never explored in terms of a reaction. So that might be what our free body diagram now looks like, with an inclined force occurring. What are the formulas that you're going to need to use? I wonder if you can remember what those are. All right, for those of you playing at home, we have force vertical equals force sine of theta, and force horizontal equals force cos of theta. Well done. Okay, analyzing the forces. In this case, I've said that we've got a force of 400 newtons, and it's coming at that angle of 50 degrees. So what do we have to do? Well, first, we must analyze the forces in their individual components. Okay, now remember how we go about doing that. Forces vertical equals force sine of theta. In this case, it's 400 sine of 50. If we punch that into our calculator, remember to make sure that you're in the correct mode on your calculator, because if you're in the incorrect mode, it will give you all sorts of silly results. That gives us a vertical force of 306 newtons, and it's going to be in the middle because I've said that the force system is pushing into the middle of our beam. Okay, and that is of course in the downwards direction. And our force horizontal is then force cos of theta. 400 cos 50 gives us a result of 257 newtons. Now, it is pushing towards the right. Okay, so we now need to solve the reactions. We know that we've got a vertical force of 360 newtons pointing down, and we know that we've got a horizontal force of 257 newtons pointing across towards the right. So, if we've got sum of forces equals 0, sum of forces vertical equals 0, and sum of forces horizontal equals 0, we can therefore try to solve our reactions on the right. And we're going to start with our vertical. 306 multiplied by half. That's probably a sort of an abbreviated way of doing it. Okay. And our force vertical on the left is also going to be 306 multiplied by half. So if we consider those, because it's nice and easy, it's smack bang in the middle, we can then understand that we have two equal reactions on either side of the system, 153 newtons, both pushing up. So therefore, in the horizontal direction, pushing into our right-hand support, what are we experiencing? We've got only one reaction, okay, and we've got 257 pointing in to the right. So our equal and opposite reaction then on our reaction horizontal is then 257 newtons pushing back to the left. Hope that all makes sense.